we'll study our second machine learning algorithm, and that is your naive-based classifier. Okay, very, very famous, especially for the text purpose. When you are dealing with a natural language processing, this performs awesome. Okay, but remember, it's the name itself is saying it's a classifier, so only thing it can do is a classification. Okay, it's a classification, and very, very simple algorithm. It is very simple algorithm, very much like whatever we have studied in the, I think, in class 12 probability. Same thing is there. Okay, just that people have used it properly. So what is that? Understand? Let me come here and let me mention here. What is that? Or let me do one thing instead of this. Let me pick this name. That is bad. Okay. So what is a naive-based classifier? Actually, it is coming from the two words. One is naive. Okay. Second one is Bayes. What is Bayes? Bayes means Bayes theorem of probability. Right? And naive, that is actually an assumption. I'll tell you what is that. Okay, so they have applied some assumption, which is a naive assumption, to the Bayes theorem, and they come to a algorithm which is known as naive-based classifier. But remember, it's only a classification algorithm. Okay, it cannot do regression. Okay, only thing it can do is a classification. It cannot do regression at any cost, right? So as I told you, it's based on two things. One is your Bayes theorem, and second one is a naive assumption. First, let me say what is the Bayes theorem. What Bayes theorem that? Bayes theorem is basically for the conditional probability, right? What it says. Suppose I want to find out the conditional probability of event A when event B has happened or event B is given to you. Okay, we have to find out the probability of A given B. Then what it will be? The Bayes theorem says that will be nothing but probability of B given A into probability of A divided by probability of B. That's a simple theorem. If few people have remember, if you people can recall, during the conditional probability in BTEX or in your class 12, okay, you must be knowing the what is the Bayes theorem. Okay, if you don't know, remember this thing. It is basically a conditional probability, means tell me the probability when event B has happened, something like that. Or B is given, tell me what will be the probability of A. Okay, so probability of A given B is equal to probability of B given A into probability of A upon probability of B. Understand this, everyone, right? What is that? Now, where is the term? Remember, every term has a meaning here. This particular term is known as posterior probability. Posterior probability, right? This particular term is known as likelihood. Okay, this particular term is known as prior probability. Prior probability, and this is also known as prior probability. I'll tell you what do you mean by prior and everything. Prior probability. Probability. Right? So remember, whenever you want to find out the probability in this condition, right, we use Bayes theorem. Okay, but what we do in the Bayes theorem, understand everyone, how do we compute the Bayes theorem? In how it is helpful in the machine learning. Okay, let me take that example. Okay, so an actual scenario will be something like this. You will be given some input parameters like x1, x2, x3, and x4. These are input parameters, and this is your output parameter. These are input, and this is your output. And what it is showing actually, suppose x1 is given, anything it is given, suppose 1, 3, 4, 5, does not matter, whatever it is given. Okay, when x1 is this, x2 is this, x3 is this, x4 is this, your output is suppose class 1. It belongs to class 1. When x2 is 2, this is 4, this is 5, this is 6, this is again suppose class 1. Okay, when this is 4, this is 5, this is 6, this is 7, this is class 2. Okay, and again suppose this is 2, this is 7, and this is 4, and this is 8, this is class 2, something like this. So this kind of data will be given to you in supervised learning machine learning algorithm. Your input will be given, your output will be given. Okay, so this kind of data set, already training data will be given to you, which will be like this, in which your input features will be given to you. Okay, and corresponding output classes will be given to you, and they will say, using this method, please train your machine learning model so that next time when I give you unseen data, how the unseen data, I will give you new value of x1, x2, x3, and x4, whatever, suppose 5, 4, 3, 2, then you have to tell me only using this. Okay, because your model has been trained on the basis of this data. On the basis of this data, my model has been trained. So it learned something. My model learned from this. In the basis of this, we find out the pattern. What is the pattern among input and output data? That's how the history has been given to us, right? Input and corresponding outputs are given. So my machine learning model learned. Now this x1, x2, x3 will be passed to this x1, x2, x3. Okay, whatever input parameters, and your model has to predict. Tell me according to x1, x2, x3, x4, which class now they will belong to. Either class 1 or class 2. This is your task. Okay, your model has to predict what, which class it will belong to. If you give unseen x4, x1, x2, x3, x4, tell me what will be the output, means which class they will belong to, class 1 or class 2. First tell me everyone, objective is clear. Then we'll come to the how we will do that with the help of this. Please tell me first this. Okay, so
Yes, sir.
training data will be given to you, in which input will be given to you, corresponding output classes will be given to you. Your machine learning model will learn from this. Your learning will be done, and after that will pass unseen data. And what is the task of a model? Using this unseen data, tell me this unseen data belongs to which class, class 1 or class 2. Clear? Fine, everyone.
Yes, sir.
Now see how we will Bayes theorem will help us out in the same case. See, these are x1, x2, x3, x4. Okay, I can write them as a vector. Suppose a capital X. I can write them as a vector capital S, which is nothing but x1, x2, x3, and x4. Okay, this one. So some x1, this is x is given to you. Okay, and we can say this is your x. X1, x2, x3, x4. This value that is giving you are passing to the machine learning model, that will be your capital X. So what you have to predict, understand? You have to predict. Tell me what is the probability of belonging to class 1? What is the probability of belonging to the class 1 given X? What is X? This X1, 5, 4, 3, 2. A vector. In short, we have made a vector X. But X is what? Your X1, X2, X3, X4. So this probability you have to find out. Similarly, one more probability you have to find out. Probability of belonging to class 2 this time. Because how many classes we have? Only 2 classes. We may have 3 classes, no problem. You will do same. You will find out probability of belonging to the class 2 given same X. Same X. This one, this one, this one, this one. If you have multiple classes, you will again compute one more. Probability of belonging to the class 3 given X. You have one more class. Probability of belonging to the class 4 given X. So you will compute 4 probability if you have a 4 class. If you have 4 classes, you will compute 4 probability. If you have 2 classes, you will compute 2 probability. If you have a 3 classes, you will compute 3 probability. How many classes are available in our case? Only 2 classes. You will compute 2 probabilities. Probability of belonging to the class 1 given X. Probability of belonging to the class 2 given X. Right? So we'll compute 2 probabilities. These are not for our use because we have only 2 classes available. Now suppose this probability came around 0.6 and this probability came around 0.4. Okay, so you will check that probability of belonging to the class 1 given X is 0.6. Probability of belonging to the class 2 given X is 0.4. Which is higher probability, everyone? 0.6 or 0.4?
0.6.
Right? So we'll say that this probability higher. Hence, we can conclude that this data point 5437 belongs to which class? Class 1. Right? Similarly, if opposite happens, it comes 0.4, it comes 0.6. Now, which probability is higher? Class 2. Your class 2 probability is higher. So you'll say that my this data point belong to which class? Class 2. This is the simple thing that we have to do. Very, very simple thing. We have to compute these probabilities with the help of what? Bayes theorem. But we will do some modification. Till now, everyone, is it clear? Please tell me. That is important.
Yes, sir.
Okay, great, great. So let me clean this. Now, objective is clear. See, so you know what is a Bayes theorem? This is the Bayes theorem which is written in front of you, right? So what we can write? We can write this. We have 2 classes. So I'm saying class 1 given X. How can I write this? Will be nothing but probability of X given class 1. Okay. Multiply by probability of class 1 You'll see it is very easy thing to compute. I'll show you that. Okay. Upon probability of X. Done. Next, probability of belonging to class 2 given X, because two classes are, we'll compute two probabilities. This one, it will become probability of X given class 2, okay, into probability of class 2 divided by probability of X, right? Same expression I've written. I will compare these two. But when I compare these two, can you see both have the same denominator? Check everyone, right? Both have same denominator. So when they have the same denominator, can't I cancel them like this? Tell me everyone,
Yes,
right?
sir.
So my formula got simplified. What? This thing is not needed anymore. The bottom part. Okay. So further simplified. Now I will make further simplification. Okay. So my formula from this formula having three terms come to only two terms this time. When I compare this, but what happens? See everyone again. Where is the drawing thing? Come on. Where it is? Draw. Yeah. Yeah. I'm coming again. You cannot draw this. Okay. Again, see what assumption is. Now comes the role of naive assumption. What is naive assumption? Naive assumption here means that naive basically means which never becomes true. That is the only thing which never becomes true. But let me tell you what is that. Naive assumption means the thing which is never becomes true. But what it says, understand? It says that, as remember, we put up four parameters. I think x1, x2, x3, and x4 for the input parameters. What naive assumption says that, let us assume. What is assumption? Assumption is what? All these input parameters are independent of each other. This is the naive assumption. All these input parameters x1, x2, x3, x4 are independent of each other. This is the assumption. Why they have assumption? Just for simplification. Your calculation will become damn easy. For simplification, they've assume that all these parameters are independent means it does not have any impact on this, it does not have any impact on this, it does not have any impact on this. And because of this, what we can do, this px belong to class 1 or px belong to class 2 can be further broken down because they are independent. Okay, so this p formula will become what this time, everyone? This formula will become like this: probability of class 1 given x will now become, okay, instead of probability of x given class 1, it will become what? Probability of, what is the first element, x1 given class 1 multiply by probability of x2 given class 1. Same class 1 will remain, remember? Probability of x3 given class 1 multiply by probability of x4 given class 1. So this term broken down into that many elements are available inside the X. What are those? X1, X2, X3, X4. And this is possible only when we assume that these are independent of each other. Okay, this is possible when these are independent of each other. This term gets split into the four terms: x1 given class 1, x2 given class 2, x3 given class 3, x4 given class 4, right? And multiply by, of course, this one, last term, probability of class 1. Okay, similarly, this formula will become what? Probability of class 2 given x. Again, this will also get broken into the, how many inputs are there? 1, 2, 3, 4. 4 parts. Same. Probability of x1 given class 2 this time, because this is class 2. Multiply by probability of x2 given class 2. Multiply by probability of x3 given class 2. Probability of x4 given class 2. Okay. Multiply by probability of class 2. Okay, so we have to just calculate these probabilities, and in learning phase we will compute these 1, 2, 3, 4, these 5 probabilities in learning phase. If we have 5 inputs, this is what we do in the learning phase. Okay, this is X1 given class 1, X2 given class 2, X3 given class 2, X4 given class 4. So in learning, we will learn these parameters, corresponding parameters which are mentioned here. Understood everyone? What is Bayes theorem first of all, and what is the naive assumption, and how naive assumption is helping out in simplification process? What is the Bayes theorem? We know that this is the Bayes theorem which is mentioned here. What is a naive assumption? Naive assumption simply assumes that all the input parameters are independent of each other, and because of that, your simplification becomes this probability of x given class 1 break down into the individual parts because these are independent of each other, no effect on each other. That's why we are able to break it down into different parts. And now you will see calculation is damn easy, damn easy. I'll show you a practical example. Okay, don't worry. Coding we can done in 5 minutes. No problem with the coding. First, see how it works. Tell me, everyone, is it fine? What is Bayes theorem? What is naive assumption? That is important. What is naive assumption?
Yes, sir.
Okay.
Fine, sir.
Now let me move ahead. Okay, and let's go ahead in implementation part. Not implementation. First of all, theory is done. Let me go to the one calculation part. Okay, that will be easier. It is clear all clear. All right. Done. And let me scroll it down. Okay, suppose some data set is given to you like this: outlook, temperature, humidity, and wind. This is given to you. Okay, and this is your output parameter. What is you are seeing right now? Okay, this is your output parameter. Okay, and these are your input parameters: outlook, temperature, humidity, and wind. Right. So what we have to do? We have to what kind of task will be given to understand? Task that will be given to you something like this. Tell me, the golf will be played or not. First of all, understand what a data set is given. Data set is giving like outlook is rainy, hot, temperature is hot, humidity is high. When windy is false, means there is no wind, then they don't play golf. They didn't play golf. Okay. When it's rainy, it's hot, humidity is high, and windy is true. Again, they don't play golf. Again, when outlook is overcast, temperature is hot, humidity is high, when no wind is there, they played golf. When outlook is sunny, temperature is mild, okay, humidity is high, and no wind is there, yes, they played golf. Okay, some that kind of data is given to you. You understand that? Okay. Now they will give you in when building the machine learning model. After building the machine learning model, they will give you this. Tell me if outlook is suppose sunny. Okay, first parameter. Temperature is cool. Okay. Humidity is normal. Okay. And windy is equal to false. Tell me, as per the machine learning model, whether the goal will be played or not. Clear everyone? What will be the requirement when they will take the machine learning model? They will give you such kind of requirement. Tell me when outlook is equal to sunny, temperature is equal to cool, humidity is equal to normal, and wind is equal to false. Tell me, as per your machine learning model, whether the person will play golf or not. Understand the requirement, everyone? Okay, this is the training data which is given to you. Right now, whatever you are seeing is a training data. They will ask you in the testing data, some parameters will be given to you according to the input. And they will ask, please predict whether the goal will be played or not. First, tell me objective is clear, everyone.
Yes, sir.
Okay. Now anyone can tell me how many classes are there?
2 classes.
Very good. Perfect. Perfect. 2 classes are there, right? Awesome. 2 classes are there. What are the classes name? Classes name is yes and
Or no.
no. Right. Now count how many total inputs are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right. So we have total 14 points. Right. We have total 14 points available. Out of the 14 points, tell check how many times there are 2 classes. One class is yes class. Second class is no class. Just count how many times yes is appearing or no is appearing. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times yes is appearing. That means 5 times no is appearing. Clear, everyone? Any doubt with this? Please tell me.
Yes, sir.
right? Now let me just go back. Just remember 14 points are there. Let me go back if it is allowing me. No, it's not allowing me to go back. Just a second. Yeah, move back. Yeah, let us see. It is got dropped. No issue. Okay. Remember what was this? This was your class probability. Remember everyone? Last time was what? Class probability, right? If I ask you in the same thing right here, like here, come. Yeah, yeah. Okay. If I ask you, please tell me what is the probability of yes class in the data set? Can you tell me? In the entire data set, what is the probability of yes class? How many points are there in total?
9 by 15.
Very good, very good. Absolutely perfect. So probability of yes class is what? 9 by 14. And what is the probability of no class?
5 by 14.
5 by 14. Absolutely perfect. So two parameters we've already calculated, right? Remember what was the formula? Formula was simple this. Probability of belonging to yes class. Example, two things we have to find out. Given x and probability of belonging to no class given x. So what will the formula become? Remember, probability of x given yes into probability of yes. Remember, this was a term, right? Similarly, what is this probability? Probability of x given no into probability of no. So these probability you find out just right now. See, 9 by 14 and 5 by 14, right, everyone?
Right, sir.
So two probabilities are already done. Your 50% work is done. Now, what is remaining? This x. But remember, we have to break this x. Okay, we have to break this x. How? Depending upon the parameters. But how will we do that? For the same purpose, actually, we will create frequency tables. Okay, let me come this. What is how do we create frequency table? Let me clear everything. Okay, and come to the next slide. Come here. Here. See. Let's put one by one each parameters. Let me put a parameter known as outlook. Okay. First check in outlook how many distinct values are there. In this outlook column, how many distinct values are there? Rainy is one distinct value. Overcast is second distinct value. Sunny is third distinct value. Any other? No. Right, everyone? So how many distinct values are there? Three. Right? Tell me, everyone. Fine. In outlook column, how many distinct values are there? Three. Rainy, overcast, and sunny. So we will create a frequency table for outlook. Okay, how will we create? We will mention here. I'll show you that in 1 minute. We'll mention like this. In outlook column, we have three options: rainy, sunny, and overcast. Okay, here we will mention how many classes are there. Two classes. So we'll mention yes and no. Two classes are there. Like this. Now we will count in our data set how many times rainy is appearing when it is yes. How many times rainy is appearing when it is yes. Can you count, everyone? Please. How many times rainy is appearing when it is yes?
2 times, sir.
Yes is here, but it is overcast. Yes is here. It is sunny. Yes, here it is sunny. Yes, it is overcast. This is one, if I'm correct, right? And one more. So we have two, right? So we will mention here two, right? Now count how many times rainy is appearing when it is no. How many times rainy is appearing when it is no?
3,
One,
sir.
one, right? Two, uh, three. Perfect. So we'll mention three. Similarly, come to the sunny. Check how many times sunny is appearing when it is yes. Okay, just check. I think one is this.
3 times.
Second is this. And third is this. Yes, three times. Very good. And how many times no when sunny is appearing?
2
Everyone?
Two
times.
times.
Two times. I think we should count it here. Where is the sunny? No. And no. Yes, two times. Now similarly overcast, please, everyone.
4 times, sir.
Overcast. And yes or no? Yes, it is over. First one. Okay. Second one. Third one, 4, 1. Very good. And no, I think no, never. 1, 2, 3, 4, like 0. Right? This is your frequency table that you have created. Right? If I ask you now, please tell me what is the probability of outlook is equal to sunny when given yes, means class is yes. Can you tell me, everyone? What is the probability of outlook is equal to sunny when class is yes?
4/4.
No, 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 no. See what I'm saying? Outlook is equal to sunny.
3/9, sir.
Yes, very good. 3/9. Yes is this, right? Overall, yes is how many times? 9 times, right? 4, 2, 3. Out of which probability of getting sunny is what? 3/9. Very good. Awesome. Clear, everyone? Tell me, this is the way to do it. Varun, check it, please. What I said, probability of sunny given yes. So given yes means you will see this, right? So how many entries are there? 2, 3. Means yes already exists. So 3 to 5 plus 4. Out of which sunny is what? 3. So 3/9. If I ask you similarly, probability of sunny given no. Can you tell me, everyone? Now you can tell me in 1 second. Probability of sunny given no. Probability of sunny given no. Sorry, given no. Tell me. Very simple now. Everyone should be able to tell me now this time.
2
Sunny.
by 5.
Sorry. Can you repeat?
2/5.
Yes, 2/5.
2/5.
Perfect. Very good. Very good. Similarly, tell me probability of rainy given yes. Come on. Rainy given yes. Within 1 second, you could tell me now. 2 by.
2/9.
Very good. Probability of rainy given no. Very good. Come on. 3 by.
3/5.
Very good.
3/5.
Very good. Probability of overcast given yes.
4/9.
4/9. Probability of overcast given no is
0/5.
0. That is 0, right? This is the thing. How easy it is, right, everyone? Quickly we can do that, and let me show you that. Same thing we have done. Come here, scroll down. Check, everyone. Can you see? Exactly same thing is there. And what is the probability of sunny given yes is what? 3/9. 3 divided by 9. Probability of sunny given no. 2/5. Right? Probability of overcast given yes is what? 4/9. Probability of overcast given no is what? 0/5. Probability of rainy given yes, 2/9. Probability of what? Sorry, rainy given no is what? 3/5. I think it should be okay, everyone. Tell me. Fine,
Fine, sir.
right? Similarly, what we will do, we will calculate same thing for every column. Now see, in temperature, how many distinct values are there? Hot, mild, and cool, right? Same thing we will do this time. Whatever we discuss, same thing we will do. How? We'll mention this time hot, mild, cool. Exactly same thing. And play goal physical to what? Same thing. Yes. And no. And repeat the same process once again. Right? So can you tell me for the hot, when it is yes, how many times hot is appeared?
2 times.
2 times. Okay. 1 and 2. Very good. And no?
2 times.
1, 2, only 2. Very good. Done. Mild. Come on, Norvin. Mild. How many
4
times
times.
mild is appearing? 1, 2, 3, 4, 5, 6. Out of which yes is appearing 1 time.
4 times, sir.
Okay, 2, 3, 4. Okay, 4. And no?
2
2
times.
times. Very good. And cool, last cool is remaining. Cool is appearing 1, 2, 3, and 4 times in all. out of which yes is appearing, I think 3 times.
3 times.
Okay, it is 1. So now I think you can calculate probability. Probability of hot given yes, what will be that? Check, 3, 4, 2 are there.
2 by 9.
2 by 9, right? Probability of hot given no,
2 by 5.
2 by 5, right? So we can calculate all the probabilities. Very, very simple. Very simple way we can get that, right? So if I clear all this ring drawing and come here and check this, please. This is what? This is the one we did. Can you check temperature, everyone? Please see, right? So same way we can calculate for every column. Outlook column we already did. Temperature we already did, right? Same thing we will do with the humidity and same thing we will do with the windy. Tell me, everyone, is it okay? I don't think so. There should be any issue in the same.
Yes, sir.
Right? Very
Yes, sir.
simple, right? Once it is done, now see, this is the task which is given to you. This is the task. Okay. Now it is being asked from you. Tell me, outlook is rainy, temperature is cool, humidity is high, windy is true. Tell me the goal will be played or not. This is the classification task which is given to your model. Your model has already learned the parameters. These are the parameters that your model has learned. Okay. Now, what formula we will write? How many probabilities will compute, everyone? How many classes are there with us? 2 classes, right?
2 plus.
So 2 probabilities we will compute. How we will compute? Remember, we'll mention probability of yes given this parameter, let's say x. And one more we will compute probability of no given x. But how will we compute? Remember, by using naive assumption. Okay. In the last, of course, what will come? Probability of yes. That we already computed. I think it was 9 by 14, if I'm correct, everyone, right? And in this formula, last what will come? Probability of no. What is that? I think that is 5 by 40 that we computed in the beginning itself. But in between, what will come? In between will come first probability. Remember what was the formula? X1 given class 1 multiply by probability of X2 given class 2 multiply by probability of X3 given, sorry, class 1 given class 1. Same class we are talking about now. So probability of X1 given class 1, probability of X2 given class 1, probability of X3 given class 1, something like that. Same thing we will mention here. What? Probability of outlook is equal to rainy. A column name is what? Outlook is equal to rainy given yes multiply by probability of temperature is equal to cool given yes multiply by probability of humidity is equal to high given yes multiply by probability of windy is equal to true given yes into this probability, and we can verify from the downside. Clear all drawing. Clear this. See, everyone, please check this formula. Please compute this. Check this formula. What is that? Probability of outlook is equal to rainy given yes, because we are computing probability of yes given x, right? Probability of temperature is equal to cool given yes, yes. Probability of humidity is equal to high given yes, yes. Multiply by probability of windy given windy is equal to true given yes, yes, right? Into probability of yes, which is mentioned here. Similarly, we'll compute one more probability of no given yes. What will be that? Probability is equal probability of outlook is equal to rainy given no. Probability of temperature is equal to cool given no. Multiply probability of humidity is equal to high given no. Probability of windy is equal to true given no. Multiply by probability of no. That is what? And these probabilities we have already computed. Where are these available? In our frequency tables or even in our likelihood tables? That is a better one. Okay, so let's go to the rainy table and check the probabilities, everyone. Let's go back. What probability we need? Probability of rainy given yes, right? Rainy given yes. Go back. Rainy is available where? In Outlook. Rainy given yes. Can you tell me, everyone, what it will be? Rainy given yes. What it will be? See from the table. Rainy given yes.
2 by 9.
Very good. 2 by 9. Okay, let me zoom less so that we can see 2 by 9, right? So one probability is there for the yes probability. That is what? 2 by 9. Come on, yeah. 2 by 9 is there, right? 2 by 9. Multiply by. Second probability, what we need? Anyone tell me? For the yes class, I'm talking about.
3 by 9.
A cool given yes, right? Cool given yes. Where is the cool? Here. Cool given yes is what? 3 divided by 3, 4, 7 plus 2. 3 by
3
9.
by
Very
9.
good. Very good. Very good. Next. Probability of humidity equal to high given yes. High given yes. Tell me everyone.
3 by 9.
Again 3 by 9. Very good. Multiply by. Probability of windy is equal to true given yes. Windy is equal to true
3
given
by
yes.
9.
3 by 9. Right? Multiply by last probability of yes. What is the probability of yes, everyone? We computed in the beginning itself. 9 points are, I think, yes, and 5 points are no. So what is the probability of yes? 9 by
14.
right? See, 2 by 9, 3 by 9, 3 by 9, 9 by 14. Let's verify it from the downside. Let me zoom in less. We are all drawing. Close it. Can you check everyone? Please see the results from here. 2 by 9, 3 by 9, 3 by 9, 3 by 9, 9 by 14. Tell me. Right? This is the probability that we received. Similarly, for no class, we'll compute these probabilities this time. Probability of no, 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 given the parameters. Let's compute that. Go back. Okay. Come on, come on. Yes, yes, yes. Yeah. Okay. Little bit, little bit. Yeah, fine. Okay. So everyone, please tell me what will be the probability of rainy given no? Rainy given no is what?
3 by 5.
Very good. 3 by 5. Probability of temperature is equal to cool given no. Cool given no.
1 by 5.
Cool given no. 1 by 5. Probability of humidity equal to high given no. High given no. See everyone.
1 by 5. Sir.
High given no. See what is that?
4 by 5.
Yes, 4 by 5. Okay. Probability of windy is equal to true given no. Windy is equal to true given no. See?
3 by 5.
Very good. And what is the last? In last, what is that? Probability of no class. What is that? 5 by
5 by 14.
okay. So 3 by 5, 1 by 5, 4 by 5, 3 by 5. 3, 1, 4, 3. Remember that. 3, 1, 4, 3. Then clear all drawing. Was it? Can you check everyone? Absolutely perfect. Please check me. Right? And from this, we can identify clearly which is a higher probability, this one or this one.
No.
Yes by x1.
Sorry. Which is the higher probability?
No, sorry.
0.02.
0.02
Yes
is bigger
by
than 0.05.
0.02.
So whether tell me tennis will be played or not, which probability is higher? Yes or no?
No.
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 No is higher. So what will happen? Tennis will not be played.
Not play.
Right? So what is our class? Class is no class this time. Okay. And what you can do, the result seems very much. If you want to scale them between 0 and 1, what you can do, you can divide this by sum of these two amount. Okay. 0.051 divided by this. So it will come around 0. Although not necessary, but if you want to see the result between 0 and 1, for that purpose, you can make it like this. Okay. Means proper result. Similarly, this amount divided by sum of these two. Okay. It will make it 0.8. Now you can actually see that. Just to scale it them properly. Only just to scale them properly, this amount divided by sum of these and this amount divided by sum of these. So it is coming 0.8, it is coming 0.2. Clearly, you can see there is a huge difference. Can everyone? Can you see? It is 0.8, it is 0.2. Strongly, we can say tennis will not be played. Understood, everyone?
Yes, sir.
Okay, I think you will be able to implement it very, very well. Okay, now let's come to the implementation part. Now you understood, everyone? I think Bayes theorem is clear. How the naive Bayes classifier works.
Yes, sir.
Okay, and I'll share this PDF with you. This will be helpful for you whenever you are revising. It will help you out. Okay, this will help you out how we actually compute the probabilities. Right now, let me move ahead. Clear, done, and let me come to notebook part. Clear. Open a new file. New Python 3 notebook. Okay, and let me import some necessary libraries. Import pandas as PD. Let me import numpy as np. Let me import cborn as SNS. Okay, I'll do quick today because we already understood every process yesterday. No problem. Come on. Okay, let me read a data set. df is equal to pd dot read underscore csv, and suppose I'm reading. Come on, read it. Titanic dot csv. Done. Let me check the data set. df dot head. First 5 rows are the same. Fine. And this is a classification problem because our output column is a survived column. Okay, we have to predict whether the person will survive or not given these parameters. If we give these parameters, these are your input parameters, and this is my output parameter. So we have to predict which class that passenger belongs to, survived class or not survived class. Okay, 1 means survived, 0 means not survived. So let me come here and check the shape of the same. df dot shape. So it has 887 rows and 8 columns, out of which 1 is your output column. So first is this. The problem is the task is the better task is classification task, as our task is to predict whether the person will survive or not. Okay, so survived column is output column. Okay, awesome, perfect. Okay, so already it's a numeric column. Perfect. This is a numeric column. This is a numeric column. That field see later on. First of all, check missing values because 2 mandatory things are there which you need to do. There should be no missing values, and second, there should be no text column. 2 mandatory things that you have to do. 2 mandatory things, right? So let me come here and check. Is there any missing value? So how do we check the missing value? df dot is null dot sum. Okay. Luckily, we don't have any missing values. Very good. If it is not having, that means we don't have to do any drop or any imputation. Already everything is there. Okay. No missing values are there. Perfect. We are good to go. Next thing. Okay. But if you see this column properly, everyone, can you say there is any column that we should drop, everyone, in this data set?
Name column.
Yes. Okay. Because name makes no sense. Every person have a different name. So how can name help in prediction or something? Right? So if such column is there, which is unique, I told you yesterday as well, I think, whenever a column is changing for every row, whenever a column is changing for every row or for every row, we have a distinct value, then that column will not help you out in any kind of prediction, right? So what you will do, you will drop that column. So what I'm going to do, how can I drop this column, everyone? df dot
df dot drop.
drop. What is my column name? I think
Name.
Okay, but directly if I drop, it will throw me an error. See, if I execute this, it will say not found in access.
X is equal
Right?
to 1.
Yes, we have to mention x. Intentionally, I'm doing the error so that you can see, right? Axis is equal to 1. Okay, and if I do this, it will not impact in my original data frame. So let me check another parameter. It has in place parameter or not. It has a parameter in place. Okay, so you want to make the changes in the original data frame, make in place is equal to true. Done. And now if I check my df dot head, I should not have any name column. Can you see, everyone? That column is gone. Clear? Tell me, everyone.
Yes, sir, clear.
Right now, only how many text columns are remaining?
1 column.
1. Very good. Now tell me, it is an ordinal variable or a nominal variable?
Sir, it is nominal variable. We have
Very
to do
good.
one hot encoding.
Yes, very good. Very good. Perfect. Okay. So we can say that the sex column is a nominal variable. So we have to do one hot encoding. Perfect. And how can we do that? We have a function for the same. What is that? pd dot get underscore dummies. And what we will pass here? Our data frame. Okay. And first more argument, remember, I discussed that tomorrow yesterday. Drop underscore first is equal to true. Okay, and save the result in my data frame. Suppose this is my final data frame. So it will pick all the text column which are available in your data frame and do the one hot encoding of them, but it will draw first column because I explained yesterday. There's no point on because same information will be communicated even we drop the first column. Doesn't matter. Okay, so if I execute this, I will get only and only numeric columns. Df dot head. Can you see? If you go there, sixth column. Can you observe everyone here? Only one column is there this time. Right? So one means it is what column? Male column. So wherever there is male, it will be one. Okay. Whenever male is not there, it is zero. That means, of course, it will be what? Female. And we can verify from the above. If you see here, what is the person name? See, the first row is of the male. So we are getting one. These are female, female, female. So what we are getting? 0, 0, 0. What is that? Male. So again, one. Help me, is it okay, everyone? Okay, so all
Okay, sir.
all the columns are numeric columns, no problem. Very good. Now let me split the data set. How can we split the data set? What we have to import is like sklearn. So import sklearn. Done. And from sklearn dot model selection dot automatically it will take, no problem. Model selection import train test split. Okay, so that we have to split our data into two parts, training and testing. Okay, so I'm gonna you mention here what train test split, but we will pass here everyone. But before passing, remember what we have to do? We have to separate our input and
Input and
output
output, sir.
parameters, right? Input and output parameters. So go back, and how can we mention? I can mention this x is equal to means all the columns except which column? Survived column. All the columns except survived column are my input column. So what I can mention, x is equal to df dot drop which column, everyone? Survived column. And which axis? Axis is equal to 1. And y is what? Y is nothing but df survived. Okay, done. And I can check this time x dot head. We will have only and only input parameters: passenger class, age, siblings, parent, children abroad, fair and sex male. Okay, we don't have a survive column. Okay, and if we go into the our y dot head, we'll have only survived column. Right? So we separated our input parameters and output parameters. Okay, same thing that we did yesterday. Now we can mention here what? X comma y input parameter, output, input variable, then your test size. I'm keeping 80% to be the test and 80% to be the train and 20% to be the test. So I put 0.2, means 20% will be test data. So automatically 80% will be your training data. Okay. And one more thing, I am putting here random state is equal to any put I can put 40. And one more thing, a classification task. So what is better? There is one more thing known as stratified is equal to y. What do you mean by that? See everyone, when the data will be splitted, okay, when the data will be split, what stratify does, it ensures that suppose in our data set we have 700 males. Suppose I'm giving an example. We have a I'm giving an example. I have a data set in which there are prediction about males and females, whether the person is male and female, and in that 700 are males and 300 are females. Okay, can you mute yourself? Agree, everyone? Somebody is actually background. Yeah, see everyone. What I was saying. So you have total 1000 rows, and your output parameter is suppose what? Gender. I'm just telling. Okay. In which 700 are males and 300 are females. So what is the percentage ratio of males? 70%. And what is the percentage ratio of females? 30%. Right. So what we want when we split our data into training and testing, same ratio should be reflected. Same ratio. In training data, there should be 70% male and 30% female. And in also test data, 70% male and 30% female. Clear everyone? What is the requirement? Okay, so whatever is the original proportion in your original data set, when you split that, same proportion should reflect in your training and testing data. So same thing here is survived column, whatever is the proportion of survived and unsurvived, same proportion should be there. That's why I mentioned how you want to do stratify. I want to do according to the output column. Okay, this is stratified sampling. I want to do stratify according to the output column, means who is my output column survived. So what this is my output class, in which if I go there and check, suppose one thing, y or something like df, I think that column has gone anymore. Let me check df dot survived dot value underscore counts. See, we have 545 unsurvived and 342 survived, right? So what is the proportion? Proportion is what? If we use calculator, what 545 divided by what will be the sum of these? I think 887. 887. Okay, 61% unsurvived. Okay, 61% unsurvived. That means 39% survived. Sorry, yes, 39% survived. So same proportion I want to keep in the training and testing data. Okay, same percentage I want to keep in the training and the testing data. Means in training, 61% should be unsurvived and 39% should be survived. Same way in the testing data, 61% should be unsurvived and 39% should be survived. So for mentioning that the same proportion is maintained, I mentioned stratify. Sampling technique. This is a sampling technique, right? I mentioned what according to which stratification you have to do. You have to do stratification according to the output column. That is my class. That's why I mentioned here why. Get it, everyone? What is the purpose of the same?
Yes, sir.
Please clear, everyone. Any doubt in this? Please tell me. Purpose. This is known as stratified sampling. Done. Right now, what it returns, everyone? Four things it returns: your training data and testing data, but X train, X test, Y train, Y test. So we have to mention that, right? We have to mention here X underscore train, comma X underscore test, comma Y underscore train, comma Y underscore test. Okay, so fourth thing it will return me. Let me equals to yes. Yes, 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 yes. Out of that, 80% data will be there, but in it, that 80%, remember that proportion has to be maintained. What I said. Okay, same proportion has to be maintained. Okay, so let me execute this. So I get my train, I get my test, right? Everything is there. Okay, X train, X test, Y train, Y test. Okay, I can directly use my machine learning algorithm now. But remember, what is the one thing? There are two flavors of naive-based algorithm. Okay, so let me actually show you what from sklearn dot naive-based import. Okay, two variants are there. One is Gaussian NB. Okay, and second one is multinomial NB. Two are there, but use cases are different. Multinomial NB actually normally used with the text data. Okay, we normally go with the text data where there is something like frequency of words. Example, something like this. Normally in NLP, natural language processing, we use it. For example, how many times the words lottery is appearing? Suppose 5 times. How many times the word is appearing? Happy. 6 times. So when we have words and frequency of words available like this. Okay, in our data set, we have frequency of words. Normally, this thing we do in the natural language processing when we want to do sentiment analysis and something. In such cases, when you have frequency of words available, we go with the multinomial algorithm. Okay, in our case, it is not required because we don't have a data like this frequency of what. Our requirement is Gaussian NB. Gaussian NB algorithm, right? And it's a class. Okay, it's a class. So what we can do, we can create a Object of the scene. How? Model equals to Gaussian NV, like this. Done. Only one step is remaining, but before that, understand. It's a probability based algorithm, not a distance based algorithm, right? So scaling of data does not matter here. I repeat, scaling of the data does not matter here because it is not a distance based algorithm. It is a your probability based algorithm. Wherever it is a probability based algorithm, it's not a distance based algorithm. In that case, scaling is not required. Okay, but Gaussian NB actually loves if your data is standard normal distributed or standardized data. Okay, if your data is standardized. For the standardized person, actually what it does, okay, suppose you have a column available like this. In X, you have value 10, 20. This is the column in which a value 10, 20, 30, 40, again 10, 20, 30. Okay, suppose this is the column given. From this column, it will calculate two parameters. One, the mean of the column, known as mu bar, or we can say mean, mu. It will compute the mean. Mean means what? Average. Average value of the column. What is the average value of the column? Average value of the values in the column. It will compute one parameter known as mean. And second parameter will compute is a standard deviation of the column. And let's say that standard deviation is sigma. So two parameters will compute. The mean means average of the column, and second one, the standard deviation. If you want to see the formula of standard deviation, let me show you that. Standard deviation formula. Yeah, this is the formula. Okay. Simple formula represented by a sigma. And how it is computed? Simple. You have a column X, suppose 10, 20, 30, 40, 50, 60, whatever it is, again 10, 20. So this individual value is known as actually your Xi. Okay, it will compute the average of the column. What is the average of the column? Suppose the average you find out is coming out to be 70. So how it will be computed? And how many points are there? 1, 2, 3, 4, 5, 6, 7. Okay, and 7 column. Okay, so this n will become 7 first of all, because we have 7 entries in this particular column. So this n is 7. We know that. Okay, suppose we find out the average of this. Okay, an average is coming up, suppose 60. So this will become 60. Right, but understand before that what mu will become 60, but how it will be computed will go x minus mu square. So what is the first element? 10. So it will do this thing, 10 minus, see everyone, what is the mean value? 60. 60 square. What is that sign? Sum, then plus. Second value was 20. 20 minus, because 20 minus mu is what? Suppose average value 60. So again 60 square, because sum is there. Again plus. What is the third element? 30. 30 minus, what is the mean value? Mean value is 60. 60 square and so on. So, okay, it will find the sum of this. After finding the sum of this will be divided by total number of elements. How many elements are there? 1, 2, 3, 4, 5, 6, 7. Divided by 7 and take under root of this. This will be nothing but your standard deviation. So in case of standardization or standard scaling, we will compute two parameters. One will be mean, okay, and second will be standard deviation. That will be sigma. Okay, so how first of all you compute this mean and standard deviation. Standard deviation will use this formula. Mean, you know that average. So what this value will transform to? This value will transform to x minus. Understand everyone? Whatever is your x, formula will become x minus mu by sigma. This will be your formula. Okay, this will be simple your formula, x minus mu by sigma. As simple as that. Okay, x minus mu by sigma. So what is x this time? 10. Like this. Suppose your mean was what? 60. So you mentioned 60. And suppose sigma came around, suppose 20, 30, whatever, you will do this. So this value will become now this new value, scaled value. Second value is what? 20. So this will come 20 minus what is mean? Mean is 60. What is standard deviation? Suppose 20. So 20. What is third value? 30. What is the mean value? 60. What is the standard deviation? 20. So this is your scaled value. But how it is? It is standardized value or standard scaled value. Okay, so if you want your data to have standard normal distribution, you can use standardization. This is nothing but standard scaling. Remember yesterday we discussed which scaling? Min max scaling. And this is which kind of scaling?
Standard scaling.
Standard scaling. Simple. You will take that value. From that value, you will subtract the mean value of the column and divide it by the standard deviation of that particular column. Every value you will compute the same way. Okay. But directly we can do that. We don't have to do it manually. Everything will be done directly. Okay. If I come here and mention, let me just change the name of this Titanic. Name. Okay. Save it. Okay. So what I will do, I'll come here from sklearn dot pre-processing import standard scalar. Okay, and again it's a class. You have to create an object of the same. So I said scalar is equal to standard scalar. Okay, and it has a two method. Remember we discussed that. What are the those methods? Fit and transform. So same thing you will one fitting. What you will find out? You will find out in the fitting two values. One the mean and second one is standard deviation. And always fitting is done on which kind of data, everyone? Training data, right? Fitting is always done on the training data. So what I will use? I will say that scalar dot. First of all, I will do the fitting. In the fitting, I will find out the mean and the standard deviation, and then I will transform fit dot underscore transform on which kind of data? On X-train data. Okay, and this will become my scale data. X-train scaled. Okay, and we will do just transformation on the test data. So we mention here X underscore happen. Let me do something here. X underscore test underscore S is equal to scalar dot transform just. So fit and transform will happen on the training data. Just transform will happen on the test data. The way we did yesterday. Okay, exactly same way. X underscore test. Done. Your work has been done now. Now directly your model is ready to be fitted. How? Come here. Model dot fit. On which data we fit, everyone? Training data. So what we will pass here? Extreme underscore S. Scale data, right? And Y train. Exactly same process. So my model will get trained, and while training, what it will learn? Remember all those probability that we are seeing, class probability, right? Your likelihood, right? So everything will be calculated now. Your frequency tables will be calculated internally. Those values will be picked up. Everything will happen here. Clear, everyone? What is going to happen?
Yes, sir.
Right? Now let me fit it. Very simple. Done. My model has been trained. Now you can use it to predict. Easily you can predict it. Why? I will say model.predict. Now what you want to predict? I want to predict the value of Y test from the X test. So I'm going to pass here X underscore test underscore S, the scaled value, right? And from this, I will predict the corresponding Y value. What is the corresponding Y value? Okay, predicted value, I'm guessing. What prediction it will do from the test value? Let me do that. Execute. Okay, your actual values are available where? Remember, your actual values are still available where? In the Y test. So we'll compare these value with these value. Okay, this is the true values of the Y test corresponding to X test. This is the prediction. So how will we compare? How is my prediction? So for that, we have to import the matrices. So I'm going to say from sklearn dot matrix import example accuracy score. For right now, I'm doing okay. Later on tomorrow, I'll continue with the same. Let me just finish it. Okay, accuracy score. So what it means, see, accuracy score. It needs two parameters: Y true and Y test. Go there and check Y true and Y pred. What is the true value? True value is the test value, right? Not the predicted one. So Y underscore test is your true value. What is the predicted value? What is that predicted? Y pred. Execute. It is giving me 75.84% accuracy. Right? You want to see, okay, my model, how my model is performing even on the training data. So let me do that. No problem. I can say Y pred train equals to model.predict. We want to predict the value of Y train from the X train. So I mentioned here X train. underscore S. Done. And again, let me calculate the accuracy, how it is performing even on the training data, the data from which it has learned. So again, accuracy score. What is my actual value this time? My actual value is y underscore train, right? What is my predicted value? This value, y pred train, from which I will compare y pred train. Execute this. Done. It is performing better on the training data, of course, because it has learned from this, but little less better on the testing data. We'll improve that later on. Don't worry. We'll improve this accuracy. There are different methods by which we can improve this accuracy. Right now, we have not done any feature engineering. Very, very simple thing, basic thing we have done. But you should understand the process first of all. The flow should come. Everything that we did yesterday, same thing I did yesterday. Right, everyone? Any doubt in today's class? Please tell me.
Sir, one small thing.
Mm-hmm.
Uh, Earlier you mentioned that the algorithms which are based on probability,
Mm-hmm.
we don't need to calculate the, we don't need to scale them.
Yes, yes.
So
Today also I said the same thing.
yes, sir. So is it will be okay if I don't scale
Yeah,
this
it is fine.
and
It is fine, but actually you should try to do what algorithm definition says. Algorithm definition says, I love if you give me the data, means performance will be better. If you try to scale, because this algorithm, for this particular algorithm, Gaussian NB, it loves data to be in a standard normal distribution. It loves that. Okay. So if your data is that form, its performance will be better. That's why I scaled that. For the point, this is the requirement of this particular algorithm. That's why I did that. This algorithm loves the data to have in a standard normal form. If you don't do even, it will work. No problem. Let me show you that. Not a huge difference will be there. Directly, what is that? X train is there now. So let me create one more instance. Suppose model 1, okay, equals to Gaussian NV. Okay, let me fit on directly my X train and Y train. Done. And let me do the prediction. Let me copy this. Okay, so Y pred T, I'm making it from the only X test without scaling. I'm directly passing it. Model, what is the name? Model 1. Okay, model 1 dot predict. Model 1 dot fit, model 1 dot predict. Okay, let me calculate accuracy score. And what is that? Y test. So Y underscore test. And it is your Y pred T. See, almost same. There is no major impact. Can you see everyone? 75.84. Can you see,
yes,
Varun? Right? That's why actually it's not effect, but we should do what algorithm says better. It loves data in the standard normal form. But you see, there is no impact of the scaling. Can you observe?
yes, sir.
Exactly same result we got, right? Okay.
And sir, one more thing.
Uh-huh.
Sir, how would we know that we have to go for min-max scaling or standard scaling?
See, whenever data is normally 99% standard scaling is used. Trust me on the same, because it makes your data in the standard normal form, and algorithm loves to have the data in the standard normal form. So better, most of the time, you ask me personally, 99% time I go for the standard scaling only, because I'm satisfying the scaling requirement. At the same time, I'm making sure that my data is in the standard normal distribution form. Okay, so 99% time you'll go for the standard normal distribution form.
Okay, sir.
Got it? Yeah. So two purposes are getting satisfied at the same time, right?
Yes,
So
sir.
I'm okay. So I'm ending for the day, everyone. Bye bye. Take care. Bye.
Okay, thank you, sir.
Okay. Bye.